I'll be showing you how to sketch the graphs of polynomial functions with another example. So in this example, you can see that there's a leading coefficient of -2. So we know that that's going to affect the end behavior. But first, we need to determine the zeros. So there are there are actually 4 factors. This is a factor, another factor, another factor, another factor. But the factors that count toward the x-intercepts are 3. So there's the x minus 1, the zero of which will be s equals 1. So that will be s equals 1 coming from this factor. And there is s equals 2 coming from this second factor, x equals 2. And then there is s equals -1 coming from this factor, x equals -1. So we found the zeros. The next thing is to determine the overall degree of this function. So we can see this linear function factor. So it's a linear factor with a degree of 1 there, quadratic factor, and a cubic factor. Altogether, that will be 1 plus 2 plus 3. That will be 6. The degree is 6. Degree is 6. And with a leading coefficient of negative. So the end behavior will look more like the quadratic function that is facing down because it's an even degree. So we'll expect that overall the graph will start from negative and then we'll finish negative, because that's how the quadratic function looks when it's facing down. So it's going to start from negative and finish negative, from negative infinity and go down to negative infinity at the end. So we can say that as x goes toward infinity, f of x is going to go toward negative infinity. And as x goes toward negative infinity, f of x is going to go towards negative infinity as well. That's the end behavior. Okay, with that being said, now we need to try to make a graph of this. So we are going to draw our x and y coordinate over here. And we're going to put these zeros as the x-intercepts from least to the greatest. So there's going to be a -1 here. And there will be a 1 and a 2. Okay, so the next thing we're going to try to do is to figure out the behavior around the x-intercept. This is a linear function, so it's going to be behaving either just like almost like a line going through the x-intercept, either like that or like that. Get another pen. So it's going to look either going that way or going this way. This quadratic around the x-intercept is going to be a bounce. Either it's bouncing up or it's bouncing down. It doesn't matter. So it's going to be like that or like that at the x-intercept. This one is going to be crossing like that or like that. This is cubic. So around the x-intercept, it's going to behave just like a cubic function. So it's going to behave just like this. That will be the x-intercept. Or it could also behave the other way, like this. Okay, we're going to see either this or this. So our next job now is to start drawing this graph, starting from negative infinity. We're going to start from negative infinity, and we're going to approach the cubic intersection there. So from negative infinity, so it's going to start from negative infinity. Now remember that at this point, it's going to behave just like almost like a cubic function. So it's going to start coming like that. So it's going to like snake around, like going to go and then go up. So sort of like that. That's not pretty good, but you get the point. It's going to be almost like sneaking around there. And then it's going to go to x plus 1 is linear. So we know it's going to go to the relative maximum and then come down like a line. And now at the x equals 2, it's going to behave like it's going to bounce. Since it's going to end down, so it has to bounce. It has to go to a relative minimum, go back up, and then bounce, and then go to infinity, to negative infinity. So basically, that's how the sketch of the graph will look. Summary is you need to analyze the x-intercepts, determine from the multiplicity of each factor how it's going to behave at the x-intercept. Multiplicity of 1 is going to go straight through. Multiplicity of 2 is going to bounce. Multiplicity of 3 is going to also go through, but not like a line. It's going to go through like almost like it's snaking around there. And that's what we have right here. And you know it's going to start down because it's an even degree with a leading negative coefficient, and it's going to end down as well. Those are the basic elements, basic things you need to bear in mind when you make a sketch of polynomial in the factored form. I hope that this video helped a little bit. Thanks for watching.